Okay, I'm Richard Friberg, and this is from chapter 3 in my microeconomics textbook. I'm going to be looking at cost minimization with two different levels of wages and see how we can use the kind of framework that we developed to say something about how the use of different inputs responds to differences in wage levels. Okay, so it's of course a stylized example, but still gives insight into why firms are choosing to produce in different ways in different countries. Okay, so we have a production of a good. So think of textiles. We're again using capital and labor as inputs. There's an isoquant like this. So same combination of inputs that give, or different combinations of inputs that give the same output produced. So we're thinking, say, 10,000 garments produced during a year, say. Okay, so to put some more context into this, think of compare Japan and Bangladesh. Not necessarily those countries per se, but something symbolizing those countries. So assume for simplicity that the production technology is the same in both these countries, so you have access to the same production function. Okay, workers are equally skilled. You can use the same machinery, etc. In the real world, that might not be true, but to highlight the differences in wages, that's a useful assumption for us. Okay, so if we're thinking of the ISO cost, so different combinations of inputs that give the same cost, so C as in cost, we have R, the rental rate of capital for a number of units of capital that are used. And think now that we're starting with Japan here. So we say that wages in Japan, or whatever they are, times the amount of labor that's used in Japan. Okay, so the cost of producing in Japan will be given by this. Okay, so that's an ISO cost that we want to draw in this figure. Okay, so to draw it, we want to have K here as a dependent variable. So we divide through by R, the rental rate of capital, and move over wage in Japan. So wages over R times L. So that's another way of expressing the ISO cost. Okay, so we have an intercept here given by C over R. We have profit maximizing choice of inputs when the ISO cost is just tangent to the isoquant. So this has now slope, negative of the slope. It's given by wage in Japan. That's not too pretty. Let's do the Japanese, honor the Japanese here and write correctly. So like that. So wage in Japan over the rental rate of capital. So we'll cost minimizing firm will choose to produce with relatively little labor and relatively much capital, KJ. Okay, if we look at the case in Bangladesh, we would say, do that in green, say. So the wages in Bangladesh are going to be lower, so we can write that just to be clear. So we're assuming there's going to be another cost level here, but that's variable. So just use C for that, R, the rental rate of capital. We assume for simplicity that that's the same in both countries, okay? And then we have wages in Bangladesh over the rental rate of capital times the amount of labor used in Bangladesh. Okay. So say that we assume that wages are lower in Bangladesh. So this is going to be the slope of that. slope of the ISO cost is going to be given by the relative price in Bangladesh. So Bangladesh over the rental rate of capital, which is assumed to be the same. Okay, so CR, we can CB, maybe be clear that this is CJ as in C Japan. So we see, costs are lower in Bangladesh, lower intercept, okay, when we are using the same rental rate of capital here. So given quantities produced cheaper in Bangladesh, and they're going to be achieving that by benefiting from the lower wages. Okay, so the point of tangency is going to be given by here. So LB and KB. Okay, so the firm facing the same technology, same capital, rental rate of capital, but lower wages in Bangladesh, is going to be choosing to produce another way in Bangladesh than in Japan. Okay, so this is intuitive, but it links and sees how the framework that we've developed can be used to make predictions about the use of inputs.